All right. Hey everybody. How's it going? Somebody here? Does it work? I can see one person here on YouTube. I hope today it's working better than yesterday where I couldn't see the chat. So give me a quick, if you're on LinkedIn, if you see this on LinkedIn, write me a quick hello that you can hear me and that you can see me in the chat, because yesterday LinkedIn didn't work, so I'm hoping LinkedIn does work today. All right. Possible, thanks. Yeah, it's working. Okay. Great. All right. Yeah, today I was like thinking it's already Wednesday, although it's Tuesday. It's like, oh man. Yeah, thanks. Okay. I can hear. All right. Yeah, I hope you had a great start in the week yesterday. As I said, I'm already like in the groove. I already think it's it's Wednesday. Yeah. Okay, connecting through LinkedIn. All right, guys. So today, what are we going to talk about today? First of all, we're going to, whenever you have questions around data engineering and so on, put them in the chat. I'm going to answer all of your questions, as always. Today, we're also going to, I'm going to create a platform architecture 2 course. And I was doing a bit of thinking of, okay, what are the typical things that you see all the time? So I put these up and I want to show you this and want to talk a bit about it. And yeah, otherwise, what has happened? Let me quickly check my LinkedIn. I did a few polls, and in these polls, there were a few interesting things that we could see. Let me quickly bring it up here. What was very interesting was here, I was asking what kind of data store do you use the most? What kind of data store do you use the most? Like I was under the impression that most likely the warehouse would have been the most, and then relational databases, and then maybe SQL databases. But actually, as you can see, it's different, right? Relational databases is the most with 45%, which, okay, it makes sense, right? That's what we learn most if you're working on transactional systems. The relational database is still king. Warehouses, although, yeah, 29%, and data lake 21%, but no SQL database or data stores. Only 5%, which is it's not a lot. It's absolutely not. Like only 5% are working with a document store or a NoSQL database like a key value store and so on, which that seems very, very low. Oh, okay, I asked the most. But I would have thought that NoSQL would be higher up here. I don't know. Like, what do you think? Do you think that is okay, or would have you also thought that NoSQL is higher? Put a 1 in the chat if you think NoSQL should be higher here, or if you would have guessed NoSQL would be higher here, and 2 no if you say no, that's all right. Or you would have guessed it like this. I think that's very yeah, it's a bit surprising. Most used or best document store. Here, MongoDB, AWS, DynamoDB, PostgreSQL, 15%. CouchDB, basically nobody uses. Where I was going off here for was DB engines ranking. And well, because when you look at DB engine ranking here in document stores, MongoDB is also here very far ahead. But then actually CouchDB is on 7th place here. And DynamoDB is 2nd. So I think it matches here. Postgres as a document store also very interesting that people actually use it as a document store a lot. Did I post something else here? That was one of the projects. Elasticsearch. Who benefits most from low-code data transformation tools? That was like, I would have guessed that engineers are first here, but also analysts. That's for the analysts. So if there is no engineering, if there are no engineers, the analysts can do data transformation with a low-code environment. So interesting. I thought that was interesting. Can you please tell us about how you've got into data journey in this sector? Would love to hear that. So for me, how I got into this, for me, I came from education, right? I had, before I studied at the university, I did a different degree. I basically below university degree where I, it's called a certified engineer in Germany. And that's where you do a lot of coding and so on. And that's how I really got started with computer science, with Java coding, with the relational databases, computer networking, and so on and so on. And then I worked for over, was it 2 years? I worked as as somebody in the company who helped people with their computer problems, basically a system admin. And after that, I was looking for jobs, and I decided actually to go into, to go basically further and study computer science. But I didn't study basically computer science. I did applied computer science, where we also had some electronical engineering and mechanical engineering stuff. So that was how I got into the whole coding and so on. And then I actually did my thesis at Bosch, Bosch Rexroth, where I did where I worked on a condition monitoring system, and then this led into predictive maintenance and large data sets, big data into Hadoop, and led me to this place now. So that's how I got into this. So it wasn't like back in the day there was no data engineer. You wanted to become a software engineer, right? And that's how I got into this, basically through software engineering. And yeah, so I stumbled into this. Right. Geekiest hangout ever. Yeah, that's usually the case with data engineers, right? Yeah. What are the best practices to create solution design doc for data engineering projects? So for me, it was always you start with a customer specification, right? You need to start with the specification to basically find out what are the needs of the customer, right? What requirements are there that you need to have a solution for? Otherwise, it will be terrible, because then the people can jump from one thing to another and change the whole thing again and so on. So your first thing, I would go the typical thing within software engineering. First, the customer specification with the customer together, and the customer is internal, right? But doesn't matter. Create a specification. What are the requirements? And then, actually, how is that called in English? Customer specification, and then you do a second specification. Customer versus customer specification versus. I actually don't know how did you name this? Basically, then the next thing is where you then create the specification of, okay, what exactly do I want to, or how do I solve this? How do I solve the requirements? And that is, I think that's a bit what you meant with solution design. But this all leads from the customer specification or the requirements specification. And what's that? In German, it's called Pflichtenheft. English. Specification book. Okay. Okay, in English, it's a bit different. Yeah, then you create the document where you basically say, okay, this is going to be the platform. These are the individual steps that we're taking. These are the tools. This is how we solve this. And for me, it was always a lot with visualizations. Just like, let me show, just like this here, have a, like, start with these kind of specifications here, where you really go in and, okay, these are the individual steps. The data is flowing this direction, this direction. This is what we're doing. And then from there you can explain more, and this is how I would start. And of course this could get very complicated, like, but we're going to talk about this in a second. So, right? Document what is the data, how does the data look, how is the data required, who is responsible for the data, and so on. Does this help, Samin? Was this something that you're looking for? Keeping generative AI in mind, what do you think would be more relevant in the future from data engineering point of view? We looked at this yesterday. In yesterday's stream, I was watching also the video from Ben Rogojan, the Seattle data guy, or we were watching them together, and I was reacting to it, where this was actually the question, and the answer to this was, of course, this is generative AI is going to help us in this. It's going to make stuff easier. It's going to solve the easy stuff for us. It's going to maybe create a boiler code where we can just then add a few things, or write us even whole codes for simple data integration. But at some point, this is going to get more complicated, and the requirements are going to get more complicated. So then you need an engineer to actually figure this out and actually then solve this. So generative AI or AI ML in general is going to help us a lot solving the easy issues, but just like with low code tools, you have your blocks, your building blocks for the simple stuff. It's all good, But whenever it gets more complicated, then you're going to run into the topic that, yeah, you need an engineer, you need somebody who's doing the custom coding, who's doing the implementation for it, because the standard blocks or the standard generated stuff from the AI is not enough. My question is more from relevance of data engineering point of view. Yeah. That's what I mean. Like from a data engineer, the easy stuff, the easy data integration, you give it you tell it the format of the data that's coming in, the destination where the data needs to go, and then a simple transformation, and boom, this is going to be generated for you, and that's it. But yeah, if it's a bit more complicated, or you need to do some design for pipelines, then this is going to be not as simple for an AI to generate. Generally. So will it be hard to transition from SSIS to Mage? Should I learn something in between? I would say this, forget about the tools. Forget about the individual tools. Right? What is the process that you most likely are going to do? You're most likely either going to do some ETL or ELT jobs. So you extract data, transform it, and then put it somewhere, or you extract data, put it somewhere, and then transform it later in the warehouse, or you do some streaming, right? If you come from a ETL tool, moving to another ETL tool or to a modern tool where you mentioned Mage here, where you do where you can add, and you can do this with most tools, add custom Python scripts, use these Python scripts in your tool, write SQL queries in it and transform it via SQL. You can even do this within Databricks and Spark. Use Spark SQL and transform the data through that. If once you can code, once you know Python, once you know SQL, you can use these tools. So it shouldn't be super hard. If there's an intermediate step, like learn something in between, for me, I don't know your background, Matthias. For me, the background would be that you look into Python and SQL. And once you know this, and you understand the data stores, where the data is coming from, where the data is going, it's easy. I've been trying to land a junior data engineering position for months with no luck. Can you give any advice? I'm a recent computer science grad. So one thing, not all data engineering jobs are called data engineer. And if you're coming from computer science, I think for you, if you're a graduate, I would not narrow it down too much on data engineer. You can always later transform or go into the engineering part. Try to get a job that is computer science heavy or computer science oriented, and that has something to do where you can work in the cloud. For me, that would be the first goal to do. Not specifically a data engineer. There could also be cloud engineer, cloud developer, or something like that. That sounds like for you that could be the first step, because that is the basis for the data engineering part. And if you're lucky and get into a bigger company, I'm not speaking about Google or Amazon or so, a bigger corporation where you may have the option to move to another department in the company. This way it will give you the option of actually then growing into that role. Especially for a beginner, I know it's hard. So I know, King, if you have tried this before, let me know. How to solve lineage problem if you have data pipelines everywhere across different infrastructure and VMs. So whenever we talk about data lineage, if people complain that they have problems with data lineage, the problem is usually with documentation, right? If once you start documenting your pipelines, documenting your data stores, then you know what is going to happen. Of course, sometimes you have tools that allow you to actually see the lineage. And I showed you this in, I showed you this a few streams back with DBT. That when you do transformations within DBT, it's going to automatically create you a data lineage. Can I bring this up? Let me see. Let me see if I can. Because I think on DBT Cloud I still have. I don't remember my login. Let me quickly see. Do I still have my DBT here? I can't show it to you now. I don't have the right things here to quickly start it up. But this way, these tools allow you to show or to automatically document the lineage if you do multiple transformations with your data. But yeah, generally, as I said, it's most of the time it's just a documentation problem. Just look into your documentation, document it better. I'm currently working on a project for our internal customers. That's good. Received the requirements and working on building a solution on AWS. Yeah, start. You can either, when you do the actual architecture, what I would use either Miro or I would use draw.io. I think draw.io also has the, you could use draw.io or you like, let me quickly see. Draw.io, discard this, discard, create a new diagram. I think that has, here's search, sorry that this is so small, AWS. Yeah, this has AWS icons here. So you could very easily, it doesn't matter. Oh no. What is this? No, I don't want to authorize this. But you know what I mean. Or you could just use PowerPoint. Go to AWS icon, download, and then they have here AWS icons. And you can either use this, but wasn't this all there also a download here? Not sure if this is the right thing. Yeah, here, this. Oops. Ah, go away. Here. You can then, you see the toolkit, and you can download here PowerPoint for dark or for light. And you can download here the asset package with all the symbols. And then just do this in PowerPoint if you're into that. Try to create the pipelines and set up the tools and so on, or select the tools. Snowflake or Databricks? Yeah, I know. It's not easy. For if you're not that much into coding, you have SQL knowledge, Databricks. Use Databricks. I'm sorry. If you have knowledge of SQL, not that much of coding, I meant Snowflake. Use Snowflake. Snowflake is easy, but super simple. And then transform the data with dbt. Easy. Everybody can get into that. As a data engineer, I have faced a lot of issues due to incomplete and inaccurate acceptance criteria. Yep. That's why whenever somebody does the customer specification, usually you need to talk with them and you accept that customer specification, right? So you need to ask them as many questions as you need to, and you need to work with them together to specify the acceptance criteria. It's very important, and then you're fine. It's going to be easy. I know most likely somebody else is going to do this and fuck this up. I know. And you then get this handed down and it's going to be terrible. But no. Can you please show dbt and how it's being used for Lineage, and does it help? Okay, let me quickly try. I need to try to bring this up. I had because I used the Docker for this. How did I do this? Let me see. Yeah. Here we go. Okay, here we are. So basically, what I did is I went to I installed dbt, and when you install dbt, you can use you go to the folder and then do dbt doc serve, and then it's going to serve the docs in user interface. So basically, it's going to create a small web server for it. If you're on dbt cloud, then you can just use dbt cloud here. It's no big deal. It's literally the same thing. But here, let me quickly see. Here you have basically this is all your lineage graph, and then you can see how did the actual tables get created, right? So for instance, the invoices table here, the invoices table got created from a countries. So let's go to that. Database, testdb, e-commerce. No, the dimension tables, or was it invoices? Then you see here invoices. This is generated from the e-commerce raw data table and the countries table. And then you could go back here. Can you actually click here? No. You can then go into countries and see, okay, countries. this is what this uses here, right? You see, this is the e-commerce table package. This was a seed file that I used. I don't know if this. I didn't create a documentation for this where I wrote that this is a seed file, but that's basically how this works, right? You have a data mart with a like an RFM analysis, and then you see, okay, where does this come from? And then you know the invoices, and here you see, okay, invoices comes out of these. That's the cool part with something like DBT, because it automatically creates this for you, right? It automatically creates this. You don't need to work on this. If you don't have something like this, you need to start and you need to document this yourself on your own. But that's why I like DBT. PySpark equals Databricks? Not necessarily. You can run Spark without Databricks, right? You can run Spark on AWS Glue. You can use Spark with AWS, how's it called? Elastic MapReduce and so on. You could install yourself a Spark cluster and run stuff. It's not necessarily Databricks, but if you want to go to the cloud and use the cloud, then you are going to be on Databricks, most likely, because Databricks is very useful and very easy to set up and work with. Yeah. So let's quickly look into what I actually wanted to show you. So from what I was thinking at, where's my Miro gone? Did I close my Miro? I think I closed my Miro board. No, here it is. Okay. Basically, I was thinking of what are typical use cases and pipelines that you find, right? And one of the typical things that you find are analytics use cases, where you are working with some kind of an analytical store, like a data warehouse, or in this case, Snowflake, where you build your warehouse on top of. And what do? Very often you have an ETL tool, and with that ETL tool, you extract data from a database, for instance, you transform it, and then you put it into the warehouse, right? That's some real basic stuff that you do. Sometimes the data is not in a database, but a system takes it and drops it into S3, into a file storage, where you then use the file, and then with your ETL tool, you write an ETL, create an ETL pipeline, and you extract the data, then the files from S3, take the data out of the files, or read the data from the files, extract it. No, that is the extraction. I meant transform it, and then upload it or write it into an analytics store, into a warehouse, into Snowflake, for instance. That's something very, very typical, very standard. With this pattern, then you also have the scheduling here, right? The scheduling could be a simple cron job. This scheduling could be internal in the ETL tool. This could be Airflow here in between, or whatever. Somehow you're going to schedule this tool, or if you want to do additional transformations, like with DBT, you could schedule this also, that the transformations happen in here immediately. So that's something very standard. Everybody uses this. I mean, have you seen this? One in the chat if you have seen this before, or if you work on this. Put a 1 in the chat. 2 for no, you have never seen this. Would be interesting. Do it while I look at something here. I see the first one. Okay. See? But this pattern is the important part, right? That's why I didn't, okay, I put here, I should have actually put here data lake. That's why I didn't really put in here tools or name of tools. This pattern is the important part. And whenever you hear Lakehouse Architecture, this is basically an extension of it, right? You could still have your ETL tool, and you work with the data, but for the Lakehouse, the important part is here: the system drops data somewhere, or either the system drops the data into S3, and then you have your warehouse, and the warehouse directly reads from this file or from your files in your data lake and works with them, right? That's one thing. So the lower part here. The other part is very often this data is not clean. So what do? You have something like an ETL tool. And we talked about this also before. You have some kind of an ETL tool for the cleaning process. So that extracts the data from the data lake, transforms the data, and loads it back into the data lake, into partitioned folders or something, cleaned and partitioned folders in the data lake. Let's replace this with data lake. Right? You could also see this like this is staging here, staging table. And then you have an external tool where you do this. Could also be that you use dbt, just like this here. That's actually a good point here. That you use an ELT tool here. Let's do it like this. That you actually have something like this. You have a system that drops the data into the data lake. This thing here, this data warehouse directly accesses the data. And then on top here, you have I need to go more right. And then on the top here, you have a ELT tool or something like, what is that now? That is our data transformation tool. Yeah. Right. For instance, you could have here dbt, right? Then you have your Lakehouse, lake and house, warehouse, data lake. I think it's very obvious. And then you do the transformation and cleaning. You do this then with a ELT data tool, right? I think these are the things that we see all the time. Yeah. Any questions on that, or should we quickly go into machine learning as well? I also have stuff on machine learning. Should we do it for machine learning? We're going to do it for machine learning as well. But if you have questions on that, put the questions in here. observations or whatever. I'm going to answer that. Then we have this quickly. When we talk about machine learning, the two things that you always see, or the important parts, is here in the middle, right? Where you have an analytics job, two analytics jobs. One is for training or for batch applying. So for the training, you're going to access data from external data sources. Going to take it, you're going to create a model for your machine learning. And either apply this directly here and put data, or put the output here into the back, and or what you do is you actually then within, if you do streaming, data comes in with a message queue, and then you have a streaming job. Let's call this streaming analytics job, and that is going to read the model and immediately apply it to the data that is coming in, and then is going to write the output data. The top one is scheduled here for your, because it's a batch job, it's a training job. You're going to do this on a schedule most likely, but the lower one here could be a streaming job. And I also think this is something, once you understand this is something very, very standard. It's always these two things, training and applying the models. And when you do the training, out comes a model file. In that are the weights and so on. And then when you apply the machine learning model, it's going to read these model files, and it's going to then apply the algorithm to the data that is coming in. It's pretty straightforward. Right? What do you think? Questions? Let me know in the comments. I know today, I feel like today is a bit of a slower day. Everybody's like, yesterday everybody was hyped. Ooh, it's Monday. I'm going to full throttle, and then on Tuesday, oh. It feels like everybody is slow today. Yeah, that was that. I don't know, what could we do? I have nothing else planned. Now we could improvise stuff. A few more questions if you want. What did I have? A few things that I actually wanted to look at. Let me see. Me post an activity. I think I liked something. Did I comment this? Where can I see likes here? Reactions. Because I actually, people were posting here incremental ETL pipelines, but that wasn't it. I don't know if this is too complicated for now. I need to look at that some other day. Whoops. Yeah. I don't have anything else. So I'm going to be back on tomorrow. And then we're going to figure out something. Yeah, I want to stream every day this week, just to get into the habit and showing you a bit of stuff. I hope this was helpful. If you're on YouTube, hit the like button if you like this, and maybe write a comment afterwards. Otherwise, see each other tomorrow. Have you had a great time? I hope you had a great time. I had. And then, yeah. See you later.